So what happens when the lights go out? For a lot of really important places, the answer is, well, not much. The power just clicks right back on. Today, we're going to pull back the curtain on the unsung hero that makes that happen, the diesel generator. Let's break down exactly how this incredible machine actually works.
You've been there, right? The power cuts out and suddenly everything goes dark and quiet. But for places like a hospital or a big data center or even your grocery store, the lights just kind of flicker and then they're back on in seconds. The magic behind that? It's almost always a diesel generator kicking into gear.
Okay, first things first, this is a super important point. A generator is not a giant battery. It's not sitting there holding a charge. Think of it more like a tiny power factory, just waiting on standby. When it's needed, it literally starts manufacturing electricity right there on the spot. It doesn't store power, it creates it.
So how in the world does it make electricity? Well, it's not actual magic, but it's based on a principle of physics that is so cool, it really might as well be. And you know what the best part is? It's actually way simpler to understand than you might think.
This right here, this is the secret sauce, electromagnetic induction. It's the whole entire game. Seriously, everything a generator does boils down to this one beautiful idea. If you move a magnet near a wire, you can get the electrons in that wire to start moving. And that flow of electrons, well, that's electricity.
Here's a great way to think about it. A generator doesn't just create electrons out of thin air any more than a water pump creates water, right? The electrons are already there, just hanging out inside the copper wires. The generator just acts like a really powerful pump, giving those electrons a big push to get them moving and create a current.
So the whole process really breaks down into two key parts. You have this stationary coil of wire, which is called the stator, and then you have a magnet spinning around inside of it, and that's called the rotor. All the generator has to do is spin that rotor. The moving magnetic field does the rest. It pushes the electrons in the stator's wires, and boom, you've got an electrical current.
Okay, so we know we need to spin that magnet inside a coil of wire. But what actually provides that spinning force? I mean, where does the motion come from? That's where the two main components of a generator come into play. You can think of them as a team, working together perfectly.
On one side, you've got a powerful diesel engine, right? And on the other, you have the electrical part we just talked about. That's called an alternator. And they are literally bolted together, connected by a single spinning shaft. So one part provides the muscle, and the other part performs the magic.
So you really have two totally distinct jobs happening. You've got the engine, that's the muscle. It's burning diesel fuel to create raw, powerful rotational motion. And then you have the alternator, that's the magician. It takes that spinning force and uses it to do the trick of electromagnetic induction we just covered, turning that simple motion into usable electricity.
All right, we have the science and we have the two key parts. So now, let's walk through the entire sequence, from a single drop of diesel fuel all the way to the lights turning back on.
It's really just a beautiful chain reaction. The engine fires up and spins the main shaft. That shaft spins the rotor inside the alternator. The rotor's magnetic field gets those electrons moving in the stator, and that creates a current. Now that raw electricity can be a little wild, so a device called an automatic voltage regulator, or AVR, smooths it all out, making it stable and safe. And finally, that clean power gets sent out to do its job.
You know, understanding how a generator works is one thing, but for the people who actually depend on them, making sure they work every single time, that's what really matters. And it all comes down to one simple word: maintenance.
And this quote right here, it just hits the nail on the head. For businesses in construction or manufacturing or data centers, a generator failing isn't just an inconvenience. No way. It's a financial disaster. Every single minute of lost power is lost money and a huge safety risk.
So yeah, ignoring maintenance is pretty much just asking for trouble. It leads to breakdowns at the absolute worst possible moments. You end up paying more for fuel because the engine's not efficient, and you dramatically shorten the life of a very, very expensive piece of equipment.
I mean, think about it this way. These generators are serious, industrial-grade engines. You wouldn't just skip an oil change on your work truck, would you? The exact same logic applies here. They need that regular care, oil, filters, inspections to stay reliable and perform their best.
You know, a solid maintenance plan doesn't have to be super complicated. It starts with simple stuff, like a daily walk-around, looking for leaks and checking fluid levels. Then, weekly, you really should test it under a real-world load, just to make sure it can handle the pressure. Monthly, you get into things like the fuel system, and once a year, get a pro to do a full inspection. It's really all about consistency. That's what builds reliability.
So now that we know how they work and why you got to take care of them, let's just zoom out for a second and appreciate how absolutely essential these machines are. They are, without a doubt, the silent backbone of our modern world.
I mean, the list is just incredible when you think about it. They're keeping life support machines running in hospitals. They're making sure our cloud data is always there when we need it. They power the huge equipment on construction sites and keep our cell phone networks online. They even power the stages at music festivals. They're just everywhere.
At the end of the day, whether it's a massive unit the size of a shipping container powering a whole factory, or a little portable one you use when you go camping, the basic principle is exactly the same. These machines are insurance policy against a world without power.
And all this leaves us with a pretty fascinating question, doesn't it? In a future that's all about electric vehicles and smart grids, our need for electricity is only going to go up. That need for reliable, on-demand power isn't going anywhere. So what role is the humble generator going to play in that electric future? Definitely something to think about. Thanks for joining me for this explainer.